Hello and welcome to the Argos Advanced Training. My name is Brian and I'll be leading the training today. The intended audience for this training is the Argos DataBlock Designer and Argos Administrator. The prerequisites to this training are the Argos Report Viewer, Report Writer, and the DataBlock Designer. The goal is to demonstrate advanced techniques such as creating multiple forms, drill down charts, creating OLAP cubes, and setting up API calls. We will be covering the following objectives in this training: an overview of the DataBlock and Administrator, how to add more forms to the dashboard and using those forms to create a drill down chart, how to add and configure an OLAP queue, and how to set up an report API. All of the objectives we're covering today in the training only apply to the DataBlock Designers and Argos Administrator. However, there is a difference between the two roles. This table shows the difference between the two user roles. Notice that the Argos Administrator has access to more operations than the DataBlock Designer. If you'd like to see all the operations available for each user role, please see the end product help. The first two topics I'd like to cover are multiple forms and charts. Depending on the amount of objects that you need on your form or the setup you're trying to accomplish, one form may not be enough. Argos allows you to use multiple forms within one data block. In our example, you'll see how a separate form can be used to display the results in a chart. And we'll take a look at how to create new forms and how they can be accessed. We'll also take a look at how to create a chart and how charts and forms can be used together to create a drill down chart. Today, we'll be working with the address information data block, the same data block you've seen in previous trainings. So let's begin by opening Argos. To add a new form to our data block, we simply click on the plus sign on the top left of the Forms tab. Now let's give this new form a meaningful name, such as what the form will contain. Since this form will contain a chart of student genders, we'll name it Gender Chart. We now have created our additional form, so all our forms will have a similar look. I saved a template with my background image, logo, data block title into the library of objects. I can now retrieve it from the library and save myself some time. Now that the base of our form is complete, we'll need a way to access this form from our main form. There are two ways a form can be accessed from another form, using a tab or via an on-click event. Let's take a look at the tab method first. To create a tab form, simply highlight the form from the Forms tab, then select the Properties tab. From the Properties tab, set the Is Tab property to Yes and change the tab to Gender. I've already made the main form a tab form, so we can now move back and forth between the two forms. So let's commit and test and see how the tabs work out. Notice that we have the tabs in the upper left corner of the screen. The tabs contains the form names, and clicking on a tab will activate that form. The second method of accessing a form is the use of an object's on-click event. For this example, we'll use labels to create a navigational menu. Clicking on a label will activate an associated form, similar to how the tabs work. We'll start by adding a label to our gender chart form. And then let's configure the label properties. And we'll use this label to take us back to the main form. So let's change the text property to main. Next, we'll configure the onClick property by clicking on the ellipses on the onClick. Select the active form from the available events list and move it over to the events list by clicking on the blue plus sign. In the form name dropdown, we'll select the main form. And we'll want a way to let the users know that the label is clickable, so we'll change the cursor property to hand point. Now, as you can see, the cursor turns into a hand point when hovering over the main label, letting the users know that this is clickable. And now that we have a way to get back to the main form, let's create another label that tells the user that what form they're on. We'll go ahead and copy and paste the main label. And we'll rename this label to gender chart. And then we'll use the alignment tool to align these two objects. And then we'll also set the cursor back to default. And then we'll remove the onClick event. We'll also want to set the text to bold. And we now have created a navigational menu on our form, so we are now able to get to our main form by clicking on this main label we created. And to get from our main form back to the gender chart, I've already created a similar navigational menu on the main form. So let's come in and test this out. Here we can navigate to the gender chart form in two ways, clicking on the gender chart label or clicking on the gender tab up here. We can also navigate to the main form by clicking on the main label or by clicking the main tab. Okay, now that we have our gender chart form ready to go, we need to add our chart object to it. And because the graph that we are creating will use a different data set than our report query, we'll create a SQL variable to return the data. From the design window, click on the variables tab and click on the plus sign to add a variable to the list. We'll use a SQL statement, so we'll leave this SQL statement radio button selected. We could select the ruler and pencil icon to go into the Visual Designer, but the SQL statements are easy enough that we'll just copy and paste into the SQL editor. For this chart, the query will count the number of males and females from the table, and we'll use a decode function to set the value of M as male and F as female. Anything other than M or F will be counted as unknown. Now that we've entered in our query, it will have to be validated before it can be used in our form. So let's click OK and click Yes to validate. Now let's give the SQL variable a more meaningful name, such as gender count. Next, you want to click on the pie chart icon to select the chart object. Holding the left mouse button will allow you to draw the chart bounding box, or you can just left click to place the object and size it later. With the release of 5.3, you now have two options for charting. You have the classic and standard. The classic charts allows you to use the look and feel of previous versions of Argos, but you can see some differences between the client and web viewer application. The standard charts have a more modern style that allows the same in the Argos client and Argos web viewer. In order to keep the look and feel of the charts the same in the client and web viewer, we'll choose the standard chart options. The series manager is what allows us to create and manage the series used in a chart. A series is basically a set of values that are grouped together for the purpose of displaying them in a meaningful way. The series section displays the available series as well as the chart types and associated dataset. Let's start by clicking the plus sign to add a new series. The Data tab is where you name the series, assign or create a dataset, and specify what field will be used as a value and what will be used as a label. We'll name the series as Gender Series. We're going to select Grade Count from the dataset dropdown. Gender count. And this is the main SQL variable we'll be using. And then we'll set the value as count and label as gender. The Type tab allows you to select what chart type to use. And the default type is the bar chart, but the other charts such as a pie, gauge, line, point, and area chart are also available. Note that a new tab was created called the bar options when that series was added. Depending on the chart type, there are additional options for displaying the chart, and here we'll see we have the option to display the chart horizontally. For this example, I'll be using the pie chart. The Labels tab is where you can configure the labels properties. Here we can choose the label style, whether or not the labels will be visible, and we'll make the labels visible and leave the label style as value. This is the chart panel window. Here we can format the background panel of the chart. I'm going to leave the default white background with no borders and click Next. The chart legend and title window allows us to configure where and how the legend and titles are displayed. Let's make the main title of the chart gender count. And also set the font to 18. And click Finish to complete our chart. Next, we'll change the variable name property of the chart to something more meaningful, since this chart will show the gender information, and we'll name it parm CHT gender. Now we can commit and test to see how our chart will look like. From here, we'll click on the Gender tab to get to the gender chart form, and you'll see the pie chart we just created with our count being displayed as our chart values and the gender as our labels. We now have learned how to create multiple forms and how to create charts. Next, we will take a look at how these two features can be combined to create a drill down effect. We will be expanding the functionality of the pie chart we just created so that when you click on a slice of pie, a breakdown of the count will be displayed. For this example, we'll break the gender count by ethnicity. We'll need another SQL variable to create our ethnicity chart, and we'll create the new variable using the same method as we did before. Let's go ahead and add a new SQL variable. And just like earlier, we'll enter our query using the free type rather than the visual design editor. For this query, we are going to get a breakdown of the student count by ethnicity based on the gender selected from the pie chart. Then click yes to validate. We don't have to enter anything in the parameter value, so go ahead and click OK to validate. Now we'll give the SQL variable a meaningful name such as ethnicity count. Next, we need to add an additional form to hold our second graph. I've already created the second form the same way we created the gender chart form and named it ethnicity drill down. If you recall, we added a form template from the library of objects to our gender chart form. I did the same thing here for a consistent look and feel. I also added the navigational labels in the same manner and simply changed the label properties. Now we'll create the new chart the same way we did the first chart. Again, we'll use the standard chart option and click on the blue plus sign to add a new series. We'll also name this series ethnicity series and select the ethnicity count dataset. We'll use the count as the value and ethnicity for the label. This time we'll display the information using a bar chart. And to keep a consistent look and feel, we'll configure this chart like we did our previous. On the Labels tab, we'll select Visible for the labels and leave the label style as value. And then click Next. And we'll leave the default background panels options. And let's set the main title to ethnicity breakdown. And also set the font to 18. And then we'll click Finish to complete our chart. And then we'll also change the variable name property of the chart to parm CHT ethnicity. Now we need to give the gender chart an on-click event, and we'll do this the same we did for the navigational labels. Let's go to our gender chart form by clicking it from the Forms tab. You want to click on the chart object so we can configure its properties, and then click the ellipses in the on-click property. We want to configure the on-click event so that when a section of the pie chart is clicked, the ethnicity breakdown for that section is displayed. To do this, we'll add an active form to the events list and select the ethnicity drill down from the form name. Now let's commit and test. Let's get into the gender form and click on male. And you'll see the ethnicity breakdown for males. And if we go back to click on the female, we can now see the ethnicity breakdown for the females. And also the same for the unknown. Next, we are going to cover OLAP data cubes. OLAP, or Online Analytical Processing, is a specific way to represent statistical data for executives, specialists, and analysts. A popular definition is a million spreadsheets in a box. And the key to the OLAP is its ability to allow the end user to configure different views of the same data. The user is presented data in an electronic spreadsheet format. By moving rows and columns or clicking on them, the user makes the system perform calculations and show data in different aspects. A new form is needed to hold the OLAP cube, which I've created ahead of time. I set it up like the other forms using the Library of Objects template and set the isTab property to yes. Next, we'll create an OLAP cube. You'll click on the cube icon and create the OLAP cube on the form by clicking and holding down the mouse while forming a square. You will see a blank OLAP cube on your dashboard. Double-click on it to open the OLAP cube wizard. The first window of the Build OLAP Data Cube wizard is where we'll configure the main properties of your cube. Use the pane on the left side of the wizard to select the generals, total, and subtotal properties to configure. Under the general section, we have the following options. We have the super saturated, and it's used for advanced calculations. However, please note, enabling this option will require more memory. We also have the exclude zeros from averages and eliminates entries that are zero from your average. You can also hide empty columns and rows, show dimensions and measure toolbars, and auto expand your columns and rows. And please note, these options will also require additional resources. When enabling one of these options, it will prompt a warning message. For example, if we were to enable the auto expand all options, it will warn us that enabling this feature may consume large amount of resources. For more information about the general options, view our in-product help by pressing the F1 key. The total section will allow you to select the location of both the row and column totals, and selecting none will hide the totals entirely. The subtotal sections allows you to choose whether or not the subtotals and selecting their positioning. For this OLAP cube, I'm going to keep all the default settings and click Next. Here is where we will build our query. OLAP cubes are populated by one or more data sets. If your data is arranged in a true star schema, you can simply create the fact and dimension table queries and link them when you configure the dimensions. If your data is not arranged in a star schema, it is typically best to simply create a single query that contains all your measures and dimensions. For this example, we're going to use only the fact table. However, if you're going to add more data sets to the OLAP cube, click on the blue plus sign at the bottom left. We'll add a data set a little later. For the fact table, I'm going to actually go through the I'm not going to go through the Visual Designer to build a query. Instead, I have a query that will copy and paste. For this example, we'll be displaying the same information as we did on the charts we created earlier. and the number of males and females and the count of ethnicity. Let's go ahead and click Next. This window is to configure the measures. The measures are the numeric items you want to count, sum, average, or perform other calculations. So this screen allows you to pick the fields from the fact table you want to measure and configure the measures options such as display, calculation, and method format. You can also create a calculated measure options which are derived from one or more fields from the fact table. You can create a calculated measure by clicking on the calculator icon, and we'll add a calculated measure a little bit later. Now let's go ahead and add our measures. We can do this by either dragging or dropping the fields from the available fields box to the measures box, or by double clicking on the fields. For this example, I want to measure the gender. I'm going to change the display name so it's easier for my users to read. So let's change this to gender. For the method of calculation, I'm going to use count. And I'm also going to change the display format. And I want to remove the decimal point, so I'm going to remove the .00. So it just reads 0. And the distinct option is to make sure that duplicates will only be counted once. We'll go ahead and leave it unchecked for now and click Next. This is the Configure Dimensions area where you can control how your measures are grouped. There are 3 tabs which are the initial locations of the dimensions. Dimensions placed in the Available tab are dimensions available for use by the report writer, but are not used as row or column dimensions to start at the start of the queue. To add the fields onto the initial location tabs, you can double click on the field, or you can click and drag the dimensions to the tab. The dimensions placed in the columns tab will default column dimensions in the queue, and I'll add the gender to the column queue. The dimensions placed in the row tab will be the default row dimensions in the queue, and I'll add description and pidim to the rows tab. And then I'll also go ahead and change these names. Beginning in Argos 5.4, you now have the ability to order the available column and row tab listings in alphabetical order. To use this feature, simply right-click in one of the initial location tab and select the sort through A through Z. You can see that the display names have been changed in the preview of the OLAP cube on the right-hand side. And it seems like I didn't get to save this. Let me do that again. There you go. In the middle, notice the other additional options we have. We have 2 options that specify where our data for that dimension is coming from. The data will come from either the fact table or from another data set. We also have the default sort method for sorting options, and forecasting, which allows you to compute trend using various methods. Please note that most forecasting methods require at least 3 data points. I'm going to leave the default settings and click Next. The last window of the OLAP Cube wizard is where you can choose a style. Select the style from the library of objects. Explore on the left, and these styles were created using the library of object manager from the main Argos interface. If you change the color theme property for the OLAP cube, it will override and remove the applied theme. I'm going to use our eVision's development standard style for our OLAP cube. And then click Finish. And now we're done with the OLAP cube setup. So let's commit and run the dashboard and see how it looks. Here is our OLAP cube, and you can see the different ethnicities and its count based on the gender. Also notice that the ethnicity on the top of the top row and the PIDM is on the bottom. This means that we can drill down the ethnicity and we can see the PIDMs that are part of that ethnicity group. So when we expand the ethnicity column, you can see it's only showing the PIDMs and the count. It's difficult to determine who falls into ethnicity based on the PIDMs. It would be easier if we can see the actual names instead. Also, some of the PIDMs have 0 across the gender, and this means that this person does not belong in this ethnicity group. So this is a waste of space for a user to see. So let's go back and make the additional changes so we can see the names instead of PIDMs and exclude them if they don't belong to the ethnicity group. We'll also add a calculated measure to show the percentage of all the ethnicities. To exclude the zeros from the OLAP cube, we can hide these values by enabling hide empty columns and hide empty rows. If we want to display the actual names instead of the PIDMs, there are 2 ways we can do this. One, we can rewrite the query in the fact table to include the names, or create an additional data set that pulls the names. For this example, we'll create a new data set. And to add a new data set, click on the blue plus sign. Let's rename this data set to name. And I'm going to pull the PIDM and concatenate the first name and last name from the sprite and table. Again, I'm going to copy and paste my query in the SQL. Next, we're going to add the dimensions and change the sprite and PIDM so it will show the names instead. Notice that the additional options appear when the from another dataset was selected. The dataset contains all the datasets that we created from the OLAP cube, and we'll select name from the dropdown. The key field is used to specify what field in the selected dataset links the fact table to the selected dimensions, and we'll select the sprite and PIDM. The data field specifies what field in the selected dataset will be displayed when the cube is ran. We'll change this to the concatenated names. And finally, we have the parent field as used to specify what field in the selected data is considered the parent of the data field. And this value can be left blank if there is not hierarchical value set. Now let's go back to the measures and create our own calculated measures. To add a new measure, you can click on the Add New Measure icon. And we'll name this new measure %pop. Notice that when we create a new measure, the calculated formula will populate with a baseline script where you can create your own calculated measure. On the bottom left, you have the available measures. That lists the measures that are available for the OLAP cube data cube based on how the cube was created. To the right are the available views, which list the different types of views or calculations available for you to use in the calculated formula. There is a sample script that can be viewed in product help by pressing the F1 key. And once you get to this page, you'll see an example of the calculation you can use. And you can use this as a reference. Let's go ahead and click Finish and commit the changes. We'll go back to the OLAP form and expand a group. And notice that we see the names instead of pitums, and we no longer see any names with zeros across the gender. You can also see our calculated measure column displaying each ethnicity's percentage by group. There are two additional options for the OLAP cubes. We have the Saved OLAP Settings and Save Settings. Save Setting allows the user to save the current settings of an OLAP cube. The saved settings include items such as the current dimensions, measures, filtering, any custom formatting, column widths, and etc., so that you can quickly return to the same cube view you had previously. Save States allows you to save the data as it was at the time of the report was ran, so it can be reproduced exactly as it was that time. When you run the report, you will be prompted to select which save state you would like to use. First, we'll go over how to utilize the OLAP settings. To use the saved OLAP settings, I'm first going to move the dimensions. Now I'm going to expand the gender, and if you want to keep this setting, you want to right-click and go to the Saved OLAP Settings and save the current OLAP settings. The Create New Save Settings window will appear, and here is where you can create a new save settings or overwrite an existing one. Type in the name of this save settings and add a description you like. You can also have the option of allowing others to see your save setting, and by checking the Share with Others checkbox, this will save settings will be available for others to use and see. If this checkbox is not checked, this save setting will only be available to you. Once you've entered a name, click OK. Now let's see how this works. So I'm going to close out the dashboard and run it again. Notice nothing is expanded and the dimensions are in different locations. I'm going to load my save settings by right-clicking anywhere on the OLAP cube and hover over the Save OLAP Settings. You want to click on the save settings we created earlier, which was example save settings. Now you'll see the OLAP cube settings has been loaded. And in version 5.3 of Argos, we also have the options to pin a saved OLAP settings. And pinning a saved OLAP setting allows you to designate a save setting as a default that will be loaded when the dashboard first runs. To pin a saved OLAP settings, we need to right-click on the OLAP cube, go to the saved OLAP settings, and click on the Manage OLAP Settings. The Manage Save Settings window will appear here, and here is where you can select an existing OLAP settings and pin it by clicking on the pin icon. Let's select our save settings and click the pin and click OK to save. Now let's see how this works. I'm going to go ahead and close out the dashboard again and run the dashboard. Notice that the dimensions are not in their default locations, and it's using the locations we specified in our saved settings. Next, I'm going to go over save states. Remember that the save states can only be created through schedules. To create a schedule, highlight the dashboard and select the schedule. Let's first deactivate the schedule. Click on the Task tab and select the Save Execution State task and click Add. This will add the Save Execution task to the added task section. And when we add the Save Execution task to the added task sections, the Save Execution State task window will appear as well. I will keep the default and click OK. Notice the schedule is now created under the dashboard. Now let's open the schedule and test it. And click Yes to continue. This schedule should finish quickly. Okay. Now to view the save state, you want to run the dashboard, and if done correctly, you'll be prompted to select a saved execution state. And notice the Select a Saved Execution State window will appear, and you can select to either run the dashboard live, load from a file, or through a save state to run. And you can also have the ability to save your save states into the file system. Our next topic is the Argos API. This is an optional module that enables the user to call Argos reports and/or schedules outside of the Argos software. Since the API can make the data available to a very wide range audience via the web server, portal, or third-party application, only an Argos administrator can enable any report that is available via the API. An API-enabled report can be executed through 3 different methods. One method is the HTTP GET request, which is much like a standard URL web page link. Another method of executing the report is via a post form, in which the calling web page gathers any needed parameters. Lastly, there's the interactive mode. When you run a report in interactive mode, the direct DataBlock dashboard launches in a restricted version of the Argos Windows client on the user's machines. Reports can use all 3 methods, whereas a schedule can only use the post and get methods. I will only show an example of the report API for this training. For this API example, I'll create an API report using the extract report and highlight the report and click on the edit report button to access the API. This is the window for the API. Notice everything is grayed out. This means that this report does not have an API enabled. And to enable the API, click on the checkbox that says make this report accessible to API. Let's first set a username and password. Now, anytime this API is called, Argos will use the administrator credentials to log into Maps and run the API. However, if you leave this blank, you'll need to pass the username and password as parameters in the API call. The variables section contains the variables from the dashboard, and these variables can be set with default values. Let's add values to the variables. The first value is our entity type code, and we'll use the %sign as the value for the entity code. Next, we'll add the values for the address type. And we'll add the following: BI and BU. Now we'll click Apply to save the changes. Notice that each sample code can either contain a HTTPS, HTTP, or both. And for this example, I'm going to place a check on the HTTPS since our map server is only accessible through HTTPS. This means that when I click on one of the sample buttons, it will generate a sample HTML code on my clipboard with HTTPS. The get and post methods are automatic modes. This means the report tasks are generated without any user interaction within Argos. Required parameters must be either predefined or gathered by the calling application and passed to the API. This is done by the use of get or the post request. For the first example, let's create an API using the get request and click on the sample get button. And this will copy the HTML code to the clipboard. Next, paste it in a notepad and save it to a location of your choice as an HTML file. Okay. Now let's open this using a web browser. And notice that we have a link when I click on the link, it will make an API call to the Argos and it will generate our report. And here is our extract report. If you attended our Argos report writer training, remember that we added a variable for the comments onto the report. We can pass parameters to the comment variable using the get method. And we'll append the following to the end of our link. We'll go &parm comments equal this is a test, and then save this and then run it again. And notice now that in the comment area, we have a phrase, this is a test. The next example is using the post method. So let's go back to the API on the report level and click on the sample post button. Similar to the sample get button, it will prompt the user that the sample code is copied into your clipboard. Let's go ahead and replace the code here with the new post method and save it and run it. Notice this time we have a button. When we click on the button, it will execute the API call to Argos to generate a report. We can also pass a parameter similar to the get method, but it's handled differently. So let's go ahead and open up the API script again. And underneath where it says all inputs here, we will need to add a new form object here and name that object with the same name as the variable. For example, to add the comments variable, add a new input underneath the all inputs here, and we're going to use the following. And this is for the comments variable, so let's save it and open it. And notice that now we have an edit box for the comments variable. Any text written in this edit box will be passed as an argument for the comments variable. Now let's put the comment, this is a test, and click the button. Again, here is our report, and notice we have our text, this is a test, under the comment section. The interactive mode allows you to call any Argos report or dashboard from portals, web page, and third-party applications. However, it does so by running a restricted version of the Argos client on the user's computer. This means the users must be able to install software on their computer to use a report in interactive mode. Users who can use the Mac PCs will not be able to execute an interactive API. Now back at the API, let's click on the sample interactive button. Now that we have the sample HTML code in our clipboard, let's paste it in the file. Now let's save it and open it. And click on the link. So now it's going to be asking us to load the application. Now we can select the parameters in the dashboard and execute the report as is. And here is my report. Okay, so we also have the Argos Web Viewer API, which was introduced in Maps version 4.3. The Web Viewer API gives users a way to enable and embed Argos reports and dashboards into another web page or third-party application or portal. For this training session, we won't be going over how to set up the Argos Web Viewer API. However, we do have documentation. It is called Accessing the Web View API, and it's available in our documentation and software webpage. In version 5.3 of Maps and Argos, we introduced the Argos DataBlock Connector. The Argos DataBlock Connector API is an optional module that provides a way to load the results of an Argos report query into third-party applications and the business intelligence tool. It uses a script to pass the parameters into the maps and then retrieve the data via a RESTful API. The results of the report query are returned in JSON format to the calling application. For this training session, we won't be going over how to set up a Argos DataBlock Connector API. However, we do have documentation. It is called the Argos DataBlock Connector Implementation Guide, and it's available in our documentation software webpage. We've come to the end of our training. Thank you for attending. Everyone have a wonderful day.